Alright, start out section 2.2. We're actually going to go a step beyond our quadratics, and we're going to deal with polynomial functions that are higher degrees than second power. So we've taken care of linear through most of your high school algebra parts, first degree. We went to quadratic. You did a little bit of that in your next sections, and in the last section of this course we did the same thing. So now we're going to go a little bit further. Now, we're going to deal a lot with graphing. So a couple characteristics of the graphs of polynomials. One of the characteristics is it's going to be a continuous graph. And this is just like it sounds. If I've got a graph that takes on, goes like this, and I never have to pick my pen up, it's continuous. Compare that to if I had something, so like I said, this is a yes, it's continuous. Compare that to one where maybe I've got a point, I start my curve up, and then I pick my pen and we've got a hole, and all of a sudden the graph continues this way. So since I'm up here, that's not continuous, so this would not be considered a graph for a polynomial. Now the other part of this, smooth rounded turns. So any graph that we do that's a polynomial is going to have these characteristics. I apologize, the technology's not working real nice here. So smooth rounded turns. In other words, something simple. Turn here, it's a curve, it's smooth, it's rounded, compared to something like an absolute value. So this would be a yes, this would be a no. In other words, if we're dealing with polynomials, that's going to be a couple of them. Alright, now there's going to be a couple general shapes that we're going to deal with here. And one thing that we're going to talk about is the term power functions. Now, no secret to this. Power functions take on a form that look like this. F of x equals x to some power. Hence, power functions. Now, the two main shapes that we're going to deal with are if that value of n is even compared to if that power of n is odd. And they're both going to have the same general characteristics. For one that's even, it's basically, and we'll take one that we've talked about already, parabola, it's going to come, touch, and turn somewhere. And it's going to go like that. A general shape for a function that's odd, where the odd exponent, third power, fifth power, and so on, it's going to come up, flatten out, go through, and go back up. Now what's going to happen is, as this n gets bigger for each of these, the shape's going to change a little bit. And the main thing is going to be the end areas, what happens out here, and what happens in the middle. So as the n gets bigger, the middle's going to get flatter. The outsides are going to get steeper. So it's almost like if you took a hold of both ends here and pushed it down, it's going to flatten the bottom out and make this get a little bit steeper. Same thing's going to happen here. Even though it's odd, it's just going to flatten out in the middle and become steeper on the edges. So that's our basic setup. So if this is a second power, we know what a quadratic looks like. It's a parabola. Well, fourth power has the same general shape, other than it's a little flatter on the bottom and steeper on the sides. Third power, x to the third, comes up, curves, comes back up this way. Same thing's going to happen with x to the fifth. It's just going to be steeper, wider, flatter, steeper. And those general shapes are always going to take on that same form. So let's look at a couple things here that we can do with these. One thing is we can simplify this into something that they call the lead coefficients. So our lead coefficients give us something called the lead coefficient test. And what the lead coefficient test is going to do is it's going to take something from a polynomial, and we've seen this a few times now, but all we're going to really worry about is this lead coefficient here, and we're going to worry about our n value up on top. So the rest of this plus blah 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 until it takes us all the way out to 8x plus a sub 0. So it's a polynomial. So here's the two things that we're going to look at. Our lead coefficient a, one of two things. Either a is going to be positive or a is going to be negative. Then we're also going to look at our n value here. Either n is going to be odd, or obviously n could be even. So 4 different possible combinations that we can deal with here. Now what we're going to look at is what they call end behaviors. In other words, what's happening on the left and right side of each of these graphs. Now one thing that you might want to think about is, think of the smallest ones here. If this is an odd, the smallest odd that we can deal with that's above second power would be third power. So if we were to think of just f of x equals x to the third power, remember that was the one that went up, curved, and went up again. So the end behavior was, on the left side it was heading down, on the right side it was heading up. So I could go something like this. There's a lot of different shapes if it's third power, fifth power, seventh power. Now if it's negative for a, it's the same thing, it just turns upside down. So this would be coming from the left side here. The right side would be the side that's heading down. Evens, think of your parabola. If this was a positive a, all we knew was left side was going up, right side was going up, and if it was second power, it just made the curve in the middle. Same thing here, if it's an even power and it's a negative, it turned upside down. So the end behavior was doing this. So again, that's just showing us what's happening on the left side and the right side, and so on. Now using that end behavior, we'll just do a couple quick little sketches here. F of x equals negative x to the third plus 4x. Again, we're not really worried about all this if all we want is end behavior. Here the a value is negative and the n value is odd. So we get negative and odd. Here's our end behavior. So this one tells me it's going to be going up on this side and down on this side. And this is a graph that actually ends up going something like this. Again, not exact, but it just gives you a little idea. Another one, we could have something like this. F of x equals x to the fourth minus 5x squared plus 4. Again, we're going to look at coefficient. Our a value is 1, so positive, so it's got to be one of these two. And our exponent is 4, which is even. So it's going to be going up and up. This is one that's actually going to do a shape kind of like a W. So those are the kind of things that we're looking for when we're trying to figure out our end behaviors and what they have to do with our graphs.